Yes, did we get it? Swasti, did we get it?
Sir.
Is it a GP, you tell me? Is it a GP? Is it a geometric ratio?
Yes, sir.
What is the common ratio?
1 by root 2.
1 by root 2, isn't it? We can, if you want, we can divide by the two terms and check 1 by 2 root 2 divided by half. We are getting 1 by root 2, right? If you want, you can check the next term also. Okay. Then what else we have to cross check? So we know R. So do we need anything else to figure out the sum up to infinity?
A.
Yes, A. Okay, A is given there. It's half, right? A is half. Okay. So sum up to infinity, directly we know. Now, yes, obviously, you have to check if it's less than 1. This is certainly less than 1, not an issue, right? But 1 by a higher number. Root 2 is 1.41, right? It's less than 1. So A by 1 minus R. So A is half divided by 1 minus 1 by root 2. You can simplify if you like. So it's root 2 minus 1. Root 2 will go to the numerator. So you can cancel it and write it as like this. You can simplify however you like. You can write it as 2 minus root 2 or something like that. Is it fine?
Yes, sir.
Okay. Yes, Niyam. Tell me how to proceed.
So we can separate the brackets.
We have to separate the brackets, you mean. So x plus x square plus x cube, okay.
Yes,
Up to infinity.
yeah.
Okay. Then you mean 1 by x plus 1 by x square plus 1 by x cube up to infinity. Okay, what next?
Then the first, like, have to use the formula.
What is the formula you have to use?
A divided by 1 minus R.
Okay, a divided by 1 minus, he's saying sum up to infinity I have to use 1 minus x. Okay. What about the next term?
It'll be 1 by x divided by 1 minus 1 by x. And
Okay, again we are using sum up to infinity. Okay. Okay. So shall we simplify this? So you're saying this is 1 by x. So after taking LCM, this will be x minus 1 by x. So x and x will get cancelled. So if I add these two, so x by 1 minus x, this will be minus 1 by 1 minus x, because x minus 1 I'll just multiply with the minus sign. So it is x minus 1 by 1 minus x. So this is nothing but minus 1. This is what you want to say.
yeah.
Okay, okay. Anybody's objection here?
Sir, but it's not given that x is lesser than 1, so you can't use that.
Okay. Niyam, you got it. They're saying that we have not mentioned that x is less than 1. So how did you use the formula is what their question is. Any justification, Niyam?
No, I just substitute the formula.
Okay, can we, if I put in the problem x is less than 1, can we solve this, Niyam, using your formula?
Yes.
So, okay, just to help Niyam out, we'll put x is less than 1 or mod x is less than 1. Is this fine?
No, sir. Then 1 by x will become greater than 1.
Oh, then 1 by x would be greater than 1. So it won't help us again. So what should we do? So, do we know what the answer is? Yes, Siri, what do you think the answer is?
So if mod x is less than 1, then we cannot use 1 by x divided by 1 minus 1 by x, because that will be more than 1.
Okay.
So for that, I think that will reach infinity. So I think the whole answer will be infinity.
Whole sum will be infinity, correct, right? It doesn't matter what x is. I think one thing we just have to mention, x cannot be equal to 1, right? That's the only condition we should have, I think, right? X is 1, it wouldn't make sense, right? Apart from that, anything would be. So suppose it's smaller than 1. Yes, you can apply a formula for here, but this all the numbers would be greater than 1, right? So it keeps on increasing and that will reach up to infinity. So the sum here is infinite. It doesn't matter if this is a finite quantity. Now, if you say you want to reduce 1 by x to be small, that time this x will be huge. right? This will go up to infinity. So either whichever you choose, the sum is infinite. So this approach, that's why I said we blindly can't just simply apply the formula, right? Right. Suppose this x was separate and this was some other variable, say y. Okay. And they mentioned mod x is less than 1 and mod y is less than 1. Then yes, this would work. This would be a different formula. This would be a different formula. Everything would be fine, right? So, but that's why the particular terms again, look at it, 1x and 1 by x, so that you're sure that if one you choose to be less than 1, other will be greater than 1. Okay, that was the whole trick to the problem. So the sum is infinite. Okay, a GP consists of even number of terms. This is clear, right? Even terms in a GP.
Yes, sir. Yes, sir.
Sum of all the terms is 3 times that of the odd terms. What does it mean? Suppose you have, say, Sn, right? Sn, the sum of entire terms. Now, if you split this sum, I say sum of even terms plus sum of odd terms. Is it okay? Right?
Yes, sir.
So what does it say? So the entire sum is equal to 3 times that of odd, right?
Yes, sir.
So what does even SE equal to? Can you tell me? What is SE equal to? You can see here itself, no? These two equations, can't you? We say Sn is this, Sn is 3s, so Sn is this also. So Sc should be equal to 2 times sum of odd numbers, right?
Yes, sir.
Okay. I'm just trying to figure out what is given in the problem, then we'll see. Determine the common ratio of the GP. That's it, that's all is given. Okay. Now what changes? Can we find the sum of odd terms separately? Like we'll take some example and just see. Say 1, 2, 2 square, say 2 cube, 2 power 4. So suppose I take only the even terms and the odd terms separate. Look at the odd terms. Isn't it the common ratio r square? Right? It's still in a GP. It's r square, right? What about the even terms? Even terms also you can see next is 2 power 5. So again, even terms also is r square, isn't it? In this particular case, it's 2 square. But you can see in the general term also, nothing would change, right? You would have, say, AR square. So if you are writing a GP only with odd terms, maybe, so AR square, A power 4, so on. So you can see that common ratio is R square. Fine. So suppose you're writing only the even, even terms now. It will be AR cube, AR power 5. Again, you can see that the common ratio is R square. Only difference is it's not starting with A, it's starting with AR. That's all. Isn't it? Fine. Okay. Anyone?
Apply the formula for the sum and then equate.
Here you mean?
No, Sn is equal to 3s.
Sn equal to 3SO here.
Like for Sn, A into 1 minus r to the power.
Yeah.
And then for S naught, we can take the common ratio as r square and the first term as AR.
Okay. So here only you'll apply in this formula, you mean, right? Okay.
Yes.
So Sn, usual formula, A into r power n minus 1 divided by r minus 1. Fine. Now 3 times SO or S naught, it basically is sum of odd numbers, right? Now we've seen that the sequence is AR square, AR power 4, right? How many terms are there? N by 2 terms, right? Because half of the terms should be there. Because we're not choosing all the n terms, the terms would be half. So A is nothing but A itself. R power, R is what? Now R is R square instead of R, correct? Because we said the common ratio is R, right? The common ratio is R square, but the power is not n, instead it's n by 2 because there are n by 2 terms, not n terms. I hope it's clear. Yeah. So n by 2 minus 1 divided by r square minus 1. Right? In place of r, I put r square, that's it. And in place of n, I put n by 2 because there are only so many terms. Okay. Now simplification, a will get cancelled. If you look at this, this is nothing but r power n itself. R power n minus 1 by r minus 1. Here we have 3r power n minus 1 divided by r minus 1 into r plus 1. It is a GP, so obviously we are not assuming r to be 1. All right. So I can cancel these and these. So all that remains is r plus 1 is equal to 3 or r is equal to 2. Is it fine? Clear? You can apply it here also. It doesn't matter. Whichever formula you want, you can apply. Either way, you would get the same answer. Could we get something?
Not the final value, sir.
Yes, yes.
So I
You
didn't
got-
get the final value, but I found the approach. I don't know if it's correct.
Okay, let's see. Let's try. So what should we do?
So first I squared TR because it's given TR.
So we want summation from 1 to 10 of TR square. So you have to square it, right? TR is given for us. So let's see, squaring, what do we get? So summation. So TR is what? 2 power r by 2 plus 2 power minus r by 2 whole square. This is what the summation we want of, right? Okay. Squaring. Again, it's still 1 to 10 itself. So it is 2 power r. Correct? A square plus b square is 2 power minus r. Plus 2 into a base 2. Right? I don't think there should be any problem. Okay. Fine. That's it, right? What is remaining? We just have to find the summation now, right?
Yes, sir.
Okay. So summation of 2 power r means what? Summation means 1 plus 2 square up to 2 power 10. This is what they have asked. Sorry, it starts with 2 power 1, not 2 power 10. So the others, they should have given r equal to 0. They started with r equal to 1. So 2 power 1 means 2. 2 r equal to 2 means 2 square, so on, right? Okay. Second part, this part. 2 power minus r. What do you mean by 2 power minus r? It is in the denominator. That's it, right? So when r is equal to 1, it is 1 by 2. When r is equal to 2, it's 1 by 2 square, so on. Similarly, up to 1 by 2 power 10. Fine? Okay. Last term is 2, it will remain 2 for all the 10 terms because there is no variable, so it is 2 into 10. Okay. Now you just have to figure out the sum of this. So what do we have? A into, how many terms is it? 10 terms. So 2 power 10 minus 1 divided by 2 minus 1 plus, right? Half into half power 10 minus 1 divided by half minus 1, which is minus. Okay. The rest is plus 20. If you want, we can simplify. This is 1. So this is 2 into 2 power 10, which is 2 power 11 minus 2 plus. Here minus sign is there, so I'll write the numerator properly. I will cancel this half, write the numerator with a minus sign. So 1 minus 2 power 10. This is it. Plus 20. If you got 532, I don't think it's right. It is a fraction, right? I don't think it simplifies. Right? So what is this? 2 power 10 is what? 1024? So 2 power 11 would be 2048. 2048 minus 2046, 2047, 2067 minus 1 by 2 power 10. I think you can keep it as it is. Unless we have made a mistake. I don't think we have made a mistake. So it's not a proper number or integer, whatever. So you would have figured out when you got the sum, right? You wouldn't get, unless you're up to infinity, yes, you could get a great number. But otherwise you would get some fraction anyways. So okay. It's just expanding and using the summation properly. That's all. You have to get used to it. Nothing new here. It's already the sum is given. Prove that. Look at this. This is such a complicated term. It turns out the formula is it's just 6n by n plus 1.
In the n plus 1, but not the same thing.
Yeah, tell me. Let's see.
So
Let's see.
I took the general form. So in the numerator, 2 is being added, and
Okay.
in the denominator, it's the addition of the squares. So I put the formula in the denominator, that is for the sum
So
of the squares.
Okay. So you mean we write the general term, is it? We write the general term. We can write it in terms of r, right?
Yes.
So general term would be what? Like if it's in terms of r, what would the numerator look like?
2n plus 1.
It is r, so I'll write 2r plus 1.
2r plus 1.
Because we can cross check. See, when r is 1, yes, it's giving me 3. When it's 2, it's giving me 5. Because this 2 into r is the common difference, right? Plus 1 is just to adjust the number. That's it. That's how you, or you can use your usual AP. It's an AP, right? You can use your AP formula, get it how we get it, right? So it's up to you. Anyways, so general term would look like something like this. So what would be the denominator?
R into r plus 1 into 2r plus 1 by 6.
R into r plus 1 into 2r plus 1 divided by 6. Okay. Right. This is the formula for sum of the squares, right? Square up to n numbers, right? So even the r term, for example, this you would do 4 into 4 plus 1, which is 5, into 2r plus 1, which is 9 by 6. This is how you figure out for this. In general, up to r terms, this is the sum. This is the sum. Okay. So what now? This will get cancelled, isn't it?
Yes, sir.
Okay. We get this cancelled. So we get 6 by r into r plus 1. What now? So this is what you are saying. You got one of the 6 term and you got this n plus 1 or something like that. That's what you are saying.
Yes.
Okay. But do you realize what we have found out right now? We just found out one of the term, isn't it? We didn't find anything. We are just generalizing the term right now. We didn't even find the sum. What is asked? We have to prove that this sum is 6n by n plus 1. What did we get? We just got a general term. For example, if you want to find Sn, we just found an right now, isn't it? One of the term. So one of the term we are saying is of this form. One of the term. For example, if you want me to write, I can write if you want like this. Say AR is 6 divided. If you want, I'll write all the terms like A1. A1 is what? 6 by 1 into 2. Right? It is the same thing. You can see that you will get 3. You're getting 3 here also. Nothing changed. We just found, for example, we'll just check, just for checking. A3 will check. 6 by 3 into 3 plus 1 is 4. So one of the two will get cancelled. So 1 by 2. Is it fine? 1 by 2. Is it fine? Let us just check the third term, just to see we are right. Okay. So 7 divided by 3 square 9. 9 plus 4, 13. 13 plus 1, 14. So yeah, 7 by 14 is half. We are correct, right? Okay. Just doing a cross check whether what we have arrived at is correct. Okay. Now the question is how to find the sum of all these numbers. Is Sn equal to summation AR? Is Sn equal to summation AR? That is the definition. Right? Sum of all terms is Sn, isn't it? Yeah? There's nothing else there. I've not written down a new formula or something. Sum of all time, I'm writing in, obviously I have to write 1 to n or something like that, right? So r from 1 to n would give me this. Okay. So I just have to find the summation of 6 by r into r plus 1, correct? If I find the summation of that should give me an answer. Yeah, till now we are trying to figure out the same thing. We don't have an exact idea how to do it, right? Look at this. I'm just going to write this in a different way. Summation of. I'll keep 6 doesn't make a difference, right? Can I keep the 6 outside? It won't make a difference. I can multiply it later instead of taking all the terms, right?
Yes, sir.
So, yeah, 6 by r into r plus 1. Now, instead of writing like this, look at the summation. I'm going to write 1 by r minus r plus 1. Does this work? Is it the same thing?
Yes, sir.
It's the same thing. Okay, okay. It's the same. So why did I write like this? Just look at this. 1 to n is what we have to add, correct? 1 to n is what we have to add. Look at the terms you're getting. 6 into, I'll write the first term now. First term is when r is 1. So 1 by 1 minus 1 by 2. Fine. This is the first term. If you want, you can cross check. See, what was the first term? First term was 3. So what is this? Half into 6. Obviously, you have to multiply with 6 to get the entire term. It's 3 still, right? We didn't change anything. We just wrote it in a different way. Okay. Where did minus come from? Okay, okay. I just wrote this in a different way. We'll come to that. How did I get it? We'll come to that. Okay. It's called splitting the terms. It's actually called as partial fractions. Okay. But we'll come to that later. I just want to get the idea, then we'll go back to the discussion. Let's look at the second term. What is it? It's 1 by 2 minus 1 by 3, correct? When r is 2, right? Now, next term, I think you get the idea. It's 1 by 3 minus 1 by 4. Okay. At the end, what do we have? At the end, what do you have? Say when r is n minus 1, when r is n minus 1, I would have 1 by n minus 1 minus 1 by n. Then the last term is n. So I would have 1 by n minus 1 by n plus 1. Is it fine?
Yes, sir.
Now look at the terms. This half and half is getting cancelled. Okay. Minus 1 by 3 is getting cancelled. All the terms are getting cancelled. Except a few. This would get cancelled with the previous term. Minus 1 by 1 and this will get cancelled. 1 by n and 1 by n. Right? All that remains is, look at the terms. 1, the first term remains here, and the last term, which is minus 1 by n plus 1. Is it fine? Now you can take the LCM. You can take the LCM. It's 6n plus 6 minus 1. Oh, okay. We are getting something different. So n plus 1 minus 1. So n, sorry. 6n by n plus 1. So here I have to multiply 6 later. So you can write n plus 1 minus 1. So 1 and 1 will get cancelled. You get 6n by n. Is it fine? This is called as telescopic series. You will see this somewhere very often later on also. The advantage of what we try to do is, see, we try to write it in a summation so that the next term, one of the term will get cancelled with the previous term. Okay. Why do we do that? We don't have any techniques. See, if it was in the numerator, I know how to find the summation r square n. When it is in denominator, I don't have any formula for it. Okay, I don't know what is some summation of 1 by r. Okay, that's a total different discussion. Summation of 1 by r. Right? So 1 by r into r plus 1, certainly we don't have anything. So what we do, we split it into terms. Now, if you want, there's a total different different way you can study all the partial fractions. Okay, there are different ways we can split it. But for now, I'll tell you the simple way. You just write r and r plus 1, whatever terms are there. If there are 2 terms, just write it in the denominator somewhere. Okay. Then just try to take the LCM and see what the numerator should be. That's it. Tell you, see, whatever terms are there. For example, instead of 1 by r into r plus 2, suppose this is your term. Or let me take still different one. Say 1 by r plus 2 into r plus 3. Numerator need not be 1 also. It can be r also if needed. Okay. Just for an example. Look at what I do. I'll write this separately, r plus 2 and r plus 3. For now, this is a technique you can use. You can have a proper technique later for partial. I'll just try to take the LCM. Look at it. So numerator, if I take the LCM of these two, what do I get? I'll get r plus 2, r plus 3. Right? Numerator would be r plus 2. Sorry, first term would be r plus 3. R plus 3. They'll take in the LCM. So next would be r plus 2. I need to get 1, so I subtract them. I subtract them such a way to get 1. Suppose I had to get 2. I'll just try to manipulate this coefficient such that I get what I want. You get the idea. If you want a better way, you write this as A, write this as B. Take the LCM, you get something like this. Equate the coefficients. What is the coefficients? Coefficient of R is A plus B. The quotient of a constant is 3a plus 2b. So a plus b should be equal to 0. Why? Because there's no quotient of r here at all, right? And constant term 3a plus 2b should be equal to 1, because this is the constant term we want. Solve these two equations. There are two simultaneous equations. You'll get value of a. Once you get value of a, you can substitute here. Now again for this problem, you'll get 1 and you'll get -1. Okay. Usually you get those terms. Why? Because they are consecutive terms. Okay. When you put 1 here, this will be 2. Sorry, when you put 1 here, this will be 3, this will be 4. So next term, when this is 4, this will be 5. So they keep on cancelling. That's how they give the terms. That's why it's called as telescopic series. You get the idea, right? So whenever you have such kind of series, always look for cancellation, right? That's how you get this sum. These are different new things, I know. I'm just trying to cover different problems as much as possible. Okay. Anyways, 11 by 18. Okay, what should we do? I don't know the answer. We'll figure out. Yes, Siri. Yes. What should be the method?
Sir, I again took a general term.
Okay, general term. Okay, I'll write in terms of. The only reason I write in terms of AR, okay, because we use n for the last term, so it can get confusing. No, nothing else. So what is AR?
1 by r into r plus t.
R into R plus 3. Let us check. So this is 1. This is 4. Yes. This is 4, 7. But R, I don't know. How is R increasing then? Are you able to follow?
Yes.
So it is, see, if I write this summation, R equal to say 1 to n. Okay. 1 to n. Using R into, so when I take 1, yeah, you're right. First term you have correctly mentioned. But when I put R equal to 2, second term should be 2 into 5. That's not 2 into 5, it's 4 into 7. Okay, I think we are trying to guess the general term. We need not guess, right? Why should we guess this? We already learned the techniques to do it. What is it? What is the pattern? 1, 4, 7. I need a general term of that. What is it? Isn't it an AP? Isn't it A plus n minus 1 into D? Isn't the A 1? N minus 1. That is what I'm trying to figure out. D is 3. So isn't it 3n minus 3 plus 1? So minus 2. So shouldn't it be 3r minus 2? Huh? We need not try to guess it. We can directly also write. We need not use this. If you want, see, for example, I will write the second term. I'll write it 3r only. Why it's 3r? Because the common difference is 3. So it should be 3r. See, whenever you are increasing by 3, what will happen? When r is 1, it is 3. Then it is 6, right? That's how you have the term 3r. The common difference will be 3r. You can use the formula. Nothing will change. If you're not sure, please use the formula. But if you know this is 3r now. The first term I'm trying to match it is 4. So 3r plus 1 is 3r plus 1. Just look at it, the terms now. When r is 1, yes, this is 1, this is 4. When r is 2, 6 minus 2, okay, and this is 6 plus 1. So you can see it is 4 into 7. And each of the terms will match, right? Okay. Now again, we have to use a similar technique. We have to split it into partial fractions. R equal to 1 and n. If you're sure how to find, it's okay. You can directly do it. Unless you think of splitting. If you want me to do the complete steps, let's do it. So A plus B. Okay. We'll take the LCM. R is equal to 1 n. So if while taking the LCM, 3r minus 2 into 3r plus 1. So taking LCM, A into 3r plus 1 plus B into 3r minus 2. Simplifying the numerator, combining r terms. Okay. If I combine the r terms, this is 3a and this is 3b. So r into 3a plus 3b. Combining the constant terms. So it is a minus 2b. That's it. Okay. Denominator remains same. Now look at the terms. So both these terms are the same. So both these terms are same. So 1 should be equal to whatever this is. Correct? Because both are the same terms. I written down it different. So r is not there at all. So the coefficient of r should be 0. That means 3a plus 3b should be equal to 0. Okay. What is the other term? Constant term. A minus 2b, this should be equal to 1. These are the two equations. Okay. Then directly from this, you know that a should be equal to minus b. Just take one term to the other side and cancel out 3. So just substitute in the other one. So the minus b minus 2b is equal to 1, or b is nothing but minus 1 by 3. B is minus 1 by 3. A is because it's minus of b, so it's 1 by 3. Simply substitute in the equation. Okay. Substitute in the equation, what do we get? A is 1 by 3. B is minus 1 by 3. Is it fine? Okay. Let's continue from with our summation. So summation is, I'll try to expand and see what happens again. Okay. When r is 1, when r, or I can take that 1 by 3 common, I think. Why should we? It's 1 by 3, right? It's there in both the terms here. See, 1 by 3, 1 by 3. Let us take it common. Let's directly do it. So 1 by 3 is common. Okay. So 1 by 3r minus 2. So when r is 1, this is 1. Okay. This is first term itself. When r is 1 for the second term, this is 1 by 4. Fine. Okay. Next. When r is 2, this will be 1 by 4. Fine. Because you can check, it's 6 minus 2. When r is 2 itself, this is 1 by 7. So I think you could guess the next term, 1 by 7. This will be 1 by 10 and so on. Again, you have to check at the end. And you can take the last term itself. You do not check n minus 1 or r minus 1. Nth term would be 1 by 3n minus 2 minus 1 by 3n plus 1. Okay, now you know that this will get cancelled, right? Even these terms will get cancelled. And at the end, you can see that this term will get cancelled with the previous term. Okay, only terms remaining is 1 by 3, 1 minus 1 by 3n plus 1. All right. So what's the answer? The answer is 1 by 3. Why? Because we are taking the sum up to infinity, not up to n. If it was up to n, we try to find the LCM. Okay. We LCM when we stop there. Now when they asked up to infinity, this goes up to infinity. This is a constant anyways. So this will be infinity. 1 by infinity is 0. So minus 0, this entire term is 0. So 1 by 3 into 1, which is 1 by 3. Okay, so usually these problems all are telescopic again. They'll either ask you up to n, just find the LCM and write your answer. That will be a formula in n. If it's up to infinity, usually you have to put infinity at the end, right? This term, usually it will be in the denominator, so it will get to 0. And the first term is a constant always, right? Because you're substituting values, right? So that would be a final answer. Is it okay? Is the technique clear? We have used a similar technique for the last problem in this, right? And it's useful throughout. Even next year you will be using. Why did we take 2a plus 3b equal to 0? What, can you speak up?
Yes, so over there you took 3a plus 3b equals to 0, right?
Yeah.
Yeah, why did we not take 3a plus 3b equal 1 by r and a minus 2b equals 0?
This numerator is equal to this numerator, correct?
Yeah.
So is there a r here? Is there a r here?
No.
Right? So shouldn't the coefficient of r be 0? Because how others, if the coefficient of r is any other constant, won't there be an r here and no r here? It won't be equal, right? It's a polynomial, right? If two polynomials are equal, you equate each and every coefficients, correct? Then only they
Yeah.
will be equal. The same thing I'm doing. I'm just equating the coefficient. Look at this. If you want, I can write this as 1 plus 0 into r, right? That's the only way these two are equal,
Oh yeah. Okay, sir.
right? So because those two terms are equal, each of the coefficients should be equal. That's all I'm equating. Yes, Ashutosh, you can tell me what have you done?
Yes, so I just observed what the answer would be for first few terms.
Okay, so what do you mean? Like you observe the first two terms.
Yes,
Is that
sir. So that would be 1 minus 4. That is minus 3.
1 minus 4? Okay, so this is minus 3. Okay,
Then for 4 terms, it would be
okay.
minus 7.
So let me see. So first two terms we already calculated. Then 9 minus 16. So it is minus 7 minus 3 minus 10, isn't it? Huh?
Yes.
So minus, yeah, I agree. This is minus 7, but you're talking about sum of all the 4 terms. You have to add all of them, right? It would be minus 10, isn't it?
Yes, then I made a mistake.
Okay. Okay. Yes, anybody else, it's some technique.
So
Yeah.
we can write it in the summation form and
Yeah.
the general form.
Yeah, tell me what summation
Like
form?
first we group 1 square plus 3 square plus 5, the odd number.
Okay. I grouped all the odd numbers.
Yeah. Then the even, like minus n and then open bracket 2 square plus 4.
Okay, 2 square plus 4 square plus 6 square. Just to see, I don't know, sum of to n terms, n is even, so I'll write here itself, right? Okay. Yeah. What next?
And then we write the summation, like the general formula for the sum of 1 square plus 3 square. plus
What
5
is it? What is it?
Summation of r till n minus 1.
This is not n minus, yeah, till n minus 1. Okay. I can write it as n minus 1 if you like. Okay, n minus 1 whole square. Okay. Yes. So what is it?
Summation of r till n minus 1 of 2n plus 1 whole square. R is equal to 0.
No, I'm not able to follow. Are you telling the summation of these numbers?
Yes, the first group.
Yeah, first sum. What is it? What is it? What did it say?
Summation of r till n minus 1. R is equal to 0.
Summation of r. First of all, isn't it r square? I'm not able to follow. Isn't summation of r?
No, not there, sir. The lower limit on that.
Yeah. Sorry.
The lower limit.
Limit, you mean?
Yes.
1 to
N minus 1.
n minus 1. Okay. Of what?
Of 2n 2n minus 1 whole square. 2r minus 1 minus 1 whole square. Yeah.
Okay. Got it. Yeah. Fine. What next?
Then the same thing for the sum
Here,
of even
in
numbers.
terms of summation, so this is 2r, right? 2r whole square, I think, right? So from 1 to is it n?
Yeah, n.
Okay, this is one of the mistake I think you have done. So this should
That
be
will be n by 2.
Yeah, n by 2. Here also it is n minus 1 by 2.
Minus 1.
Why? You can see what is happening, right? If you want, put n minus 1 here and see. If you put n minus 1, there will be 2 into n minus 1 minus 1. So it will be 2n actually, but here our term is actually, you can see, right? It's n minus 1. It's not 2n minus 1, right? You get the idea. Okay. So summation, if you want to write it like this, you can write. Or you can change this last time. It will not be n itself. You can take it as 2n. There's no rule. I know they have asked sum up to n terms. We can take up to 2n. Then at the end, what formula you get? In place of n, you can replace by n by 2. Not an issue. Okay.
Sir,
Yes.
can't we do it like we can rearrange the terms like that's in the series it's like 1 square minus 2 square. We can group it and we can write it in the form of 1 plus 2 into 1 minus 2.
Yeah. We will come to that. We'll come to your type. We'll see if this is going in somewhere. If you are stuck somewhere, we can't figure out. We'll go back to a different approach, right?
Yeah. So if you keep on adding the first two terms, you get minus
Wait,
3.
Ashutosh, we will complete this. We'll try to complete this. Then we'll
Yes.
come back. Yeah. Okay. Yes. Yes. Is this fine now, Siri?
Yes, sir.
What next? What next do we suggest? So
Not continue.
you have not continued. Okay.
No.
Okay. So do we know? Just to ask you, do we know the summation of say 1 to n? Simple 1 to n. 2r minus 1 whole square. Do you know how to find the summation of this? Just figuring out. Do we know how to find the sum? No. Anybody? Do you know how to find the sum? No one. Okay. I'll take this up in the next section. Okay. I'll just teach you after this how to figure out any sum like this given. So we had seen summation when it was in the denominator. Previous two problems, I think. You've seen when the denominator we split it and all, right? Now it's in the numerator. I've given you hints about how to write the summation. We'll look at it. Okay. We'll take this up next. Okay, fine. So we can't complete because we don't know how to find the sum. Yes.
Yes. So if you
We can write it as 1 plus 2 and
Yeah.
1.
Yeah.
So minus 1 common.
Okay. 1 minus 2 into 1 plus 2. This is what you're suggesting, right?
Yeah,
Sorry.
and then 3 plus 4 into 3 minus 4.
Yeah, 3 minus 4 into 3 plus 4. Yes, why not? At the end, should we write the last? It would be say n minus 1 minus n, right? Into n minus 1 plus n, I think. Is it fine? I think it should cover.
Yes.
N is equal. Okay. What now?
Then we notice that minus 1 is common all of them.
Yeah. All these are minus ones, right? The first term is coming out to be minus 1. So I'll just put it out, minus 1. So remaining terms is 1 plus 2, right? In the first term. Second term is 3 plus 4, correct?
Yes, sir.
Yes, I think everybody should figure out now. Next would be 5 plus 6 and so on. And the last term that would remain is n minus 1 plus n. Right? We know this summation. We have done it multiple times. This is nothing but n into n plus 1 by 2. Sum of first n natural numbers. So into a minus sign. So the final answer is n into n plus 1 by 2 with a minus. So summation, we had seen different ways to solve summations, right? But I just wanted to ask. So suppose summation 1 is given from say 1 to n. What is the summation equal to? What is the summation equal to?
N.
N, right? Not no doubt. Summation 1 to n. Again, variable is always r whenever I write. So what is this equal to? We just seen just now. The sum of natural numbers, isn't it? N into n plus 1 by 2. Correct? Fine. What is summation r square? Is somebody? Summation r square?
N into 2n plus n into 1 plus 1 into 2n plus
N into n plus 1 into 2n plus 1 divided by 6. Okay. So in the last problem, we were interested in something like summation, say 1 to n. It's not n exactly, something different, but 2r minus 1 whole square. Correct. This is what we are interested in. Fine. So can you see what is this? Summation of 2r square. Sorry, I have to square it. So it will be 4r square minus 4r plus 1, isn't it? right?
Yes, sir.
So do we know what the summation of summation r square is? We know, right?
Yes, sir.
Yes.
We know what is the summation of r also.
Yes.
We know what is the summation of 1 also. So we can figure out the summation. So those problems also could be solved. Any AP, see, what is an AP? Look at this. An AP would be something like 3r plus 2, correct? Usually it is a linear term, right? Any generic AP would be what? Say, an is a plus n minus 1 into d, correct? So it will be something of this form. Maybe 3r plus 2 or 10r plus 5, something like that, correct? So summation of this, you can find it directly from 1 to n if you want to try. You can write 3 into summation r 1 to n plus 2 summation 2, which is usually n. You can directly write. You can do this also. But we already have a formula for Sn, so we tend to use it directly. Is it fine? But this is also a valid technique. So what we are actually doing, see, we are writing summation AR. Summation AR, right? Summation AR we are writing. And this is nothing but Sn. Summation AR, R equal to 1 to n. So we already know some basic summations, that is summation R. So everything up to a quadratic equation will come under this, right? So any summation given, we can figure out. So that problem, if you want, you can go and retry the previous one. So you can try to complete it. It need not be n. It need not be n at the end of the day. If it's not n, if it's n minus 1 by 2, simply substitute n minus 1 by 2. If it's n minus 1 by 2 here, you can simply substitute n minus 1 by 2. Is it clear? So this is the summation. So now, if summation is numerator, you can again figure out. So one more summation, which I don't know whether you know or not, summation r cube, 1 to n. What is this equal to? This is also very important. Do we know this? N square into n plus 1 whole square by 4. If you look at it properly, it is nothing but summation r whole square. Fine. This is summation of r cube. That is sum of the first n natural numbers. This is the formula. Okay. So summation 1, this is pretty obvious, right? This is pretty obvious, correct? Summation r we derived, right? We used AP. So summation r is nothing but AP. So do we know how to get summation r square? Okay. Look at this. We're trying to find summation r square. R is from 1 to. Do you know this would be a cubic equation at least? Because we're adding all the square terms, right?
Yes.
At the end, we are multiplying. It's similar to multiplying one more extra term, right? When you're adding all the r square terms. So it would be cubic equation. So can I write a generic cubic equation, say an cube plus cn square plus, sorry, why should I go to C? I'll go for B. So bn square plus cn plus d. So any cubic equation will be in this form, correct? We all agree, right?
Yes, sir.
So what I'll do, I know what is summation r square, right? It's 1 square plus 2 square plus 3 square up to n square. So this I'm saying is equal to this. Okay. If you want to complete the proof, to be honest, you have to prove that every time this would be a 1 degree higher. Okay, we are just assuming that and continuing, right? But let's continue that. Okay. Here, look at it. I'll take n equal to 1. This is true, right? This formula should give me value for any n, correct? So I'll simply take n equal to 1 and check. So when I take n equal to 1, this side is 1. Other side is a plus b plus c plus d. Is it fine?
Yes.
We can take n equal to 0 also if you require. That time we'll clearly get d equal to 0 if you want. Okay. If you say no, we started with only n equal to 1, I don't want to use it, it's up to you. Okay. Because we know it should be true for n equal to 0 actually. So we get 0 both sides, right? That would make much more sense. That's why I'm saying. But if you don't want to use it, it's up to you. We can use n equal to 2. 1 square plus 2 square is 5. when n equal to 2, this is 8a plus 4b plus 2c plus d. We know what to do. We put n equal to 3, 27 a plus 9b plus 3c plus d. N equal to 3 is what? 3 square 9 plus 4, 13, 14. Right?
Yes,
Got
sir.
Now, because we didn't take n equal to 0, we have to take one more term. So we'll just try to simplify by taking n equal to 0. Okay. So this will be 0 plus 0 plus 0 plus d. Right? So d is nothing but 0. Okay. Otherwise, you have to take n equal to 4 and write another equation. Okay. The simplification, solving it will be a bit more tedious, not that, because all the d's will cancel off whenever you subtract. That's not an issue. But simply to avoid that, I'll directly put d equal to 0. Now we know d is equal to 0, so I'll simply substitute in all the equations d is 0. Is it okay? Now we have 3 equations, 3 unknowns. We know how to solve it, right? So we'll get the value of a, b, and c. If I get d, already we know it's 0. So if I get the value of a, b, and c, I got my cubic equation, what I want. Okay. If you want, we'll complete it. I'll give the other part as a homework. You can try at home. Which summation of r cube that you can try. Okay. Let's see. Let's try to complete it. So we'll eliminate c first. So I'll multiply with 2. Okay. I'll multiply with 2 and subtract. Okay, I'm subtracting. If this equation is, say, let me name the equation 1, 2, and 3. So I'm doing 2 minus twice 1. Right? Okay. So 2 minus twice 1. So 5 minus 2 is 3. Other side, 8a minus 2 is 6a. 4b minus 2b, it's 2b. C gets cancelled. The whole reason we did it because C should get cancelled. Okay, fine. Similarly, third, 3 minus, to cancel 3c, I need 3 times 1. So 3 times 1. Fine. So this is 14 minus 3, which is 11. 27 minus 3, which is 24a. 9b minus 3b, which is 6b. Now we got 2 equations, 2 unknowns. We just simply solve them. How to solve? I can multiply this with, I think, what, 4. We'll get rid of a. So it's 12 minus 11, which is 1. I'm subtracting after multiplying. So this will be 0. This will be 8b plus 2. So we got b. This implies b is half. Fine. I'm doing the solving quickly. You can take your time while solving. Okay. When a is half, I'll simply substitute in one of the equations to get b. Let me substitute it here. Okay. A is half. So 3 is equal to 6a plus 2 into half. 3 minus 1 is 2. 2 is 6a. Or this implies a is 1 by 3. I got a, I got b, I'll get c. I can use this equation. Whichever is simpler, I'm just using those equations. So 1 is equal to 1 by 2 plus 1 by 3 plus c. So c is nothing but 1 minus 1 by 2 minus 1 by 3. 1 minus 1 by 2 is anyhow half. Half minus 1 by 3. It is 1 by 6. Is it okay? Till now? Did we find a, b, and c? So did we get our formula? What is it? A is 1 by 3. So n cube by 3. What is it? B is 1 by 2. So plus n square by 2 plus c is 1 by 6. So n by 6. If you want to take the LCM, take one n common. N is common. And take the LCM. So numerator will be 2n square plus 3n plus 1. Fine. Factorize. You know it is n plus 1 into 2n plus 1 because we already know the formula. You can use your usual method. So we got back our formula. This is one of the methods. There's another method of differences also you can try to solve, right? By writing as n cube minus n minus 1 whole. It's not required as of now. Okay. I just wanted to pitch in a simpler way, right? So that you can put values and figure out the formula. So you can try for summation r cube yourself. So summation r cube will be higher degree equation, one higher. So you will get a n power 4 plus b n cube plus c n square plus dn. You can leave the e part because it's 0. Okay, when n is 0, so both sides should be 0. So I'm just leaving the e part. So this you try at home and see if it's matching to our formula. What I said. I said that we have n square into n plus 1 whole square by 4. You can try that. Can you use induction? Yes, you can use induction. Can use induction to solve. Because I have not explained induction, I have to go back and explain induction. So we're not doing induction. Induction is much more easier if you know induction. I'm just trying some other generic. Is it okay? Any doubts, you can directly speak and ask. Not type or answer. Okay.
Sure.
If not, yes.
So do we have to prove that the polynomial will have always 1 degree higher?
Yeah.
Like how are we supposed to prove that?
That actually, what you can do is you can write. Okay. You can write n cube minus n minus 1 whole cube, right? This will be a quadratic equation, right? If you subtract the n cube term,
Yes, sir.
right? Then you can, what happens is if you write down all the terms, right? What is the other side? It's a quadratic. What is it? 3n square, I'm not sure. Plus 3n. So it's a negative sign. Okay, whatever. I'm just writing. I'm not, the signs are not correct. Okay, one is minus, one is plus. I'm just giving you ideas so you can figure it. You can continuously writing down the terms. What will happen? See, this will be when I'm starting from 1. So let me say this is 1 cube. This will be 2 cube. Correct? Fine. This will be when I'm writing 2. This will be 2 cube. This will be 3 cube. Correct? Fine. Are you able to follow? So what will happen is this will be 4 cube. Sorry, this will be 3 cube. This will be 4 cube. So on. At the end, I'll come to n minus 1 cube, and this will be n minus 2 cube. Is it okay? This is also actually one of the proofs. Like you can complete the proof here, but I just wanted to give you a generic idea. That's all. So look at this. Now, if I add all these, what will happen? Isn't it something like a telescopic series? Right?
Yes,
Right?
sir.
Agree. And this side is a cubic equation, isn't it? This side is what? A sum of a quadratic equation. That's all we have to prove, right? You may say there are linear terms, but we already know that linear term, the sum will come out to be a quadratic equation, correct? Correct. And this term will come out to be a linear equation itself. So the only term giving a cubic equation is this term. So that's a good enough proof. In the simplest way. Right? Others you can think of. I didn't give you a proof, but what I said is your terms adding quadratic equation, right? You're adding for a number of terms, so there would be another n involved, right? So you get the idea. So it's a quadratic into an n. So the simplest way to but it's not a proof, just to visualize it. Okay. This actually, by this you can get the proof of a summation n square also. Why? Because here you would have summation n square. All you have to do is find the summation of this, transpose to the other side and subtract. You'll get it. You can complete this proof also if you like. This is also a good one. Is it okay?
Yes, sir.
Okay. Did we approach something? You get something. Sum up to infinity, no? Don't we know the formula for it already? We know, right? What is this? 1 is equal to, this is, if I combine this, is x square into x minus 1 or 1 minus x. Is it fine? Next term would be what? X cube, sorry, x power 4. X power 4 into 1 minus x. So if this pattern is continuing, if I take this 1 minus x common, right? 1 minus x common, what remains? x square plus x power 4 plus x power 6 up to infinity. Don't we know the sum of this already? Sum up to infinity. Anybody has an objection? I can't use sum up to infinity because I don't know what is the value of x and something. Obviously, we can't have x equal to 1. That wouldn't make a sequence. It would be zeros anyways, right? And 0 power infinity, it won't be defined. It should be certainly not for x equal to 1. For any other value, I don't. Because they have told us sum of all can be represented in this. Suppose I assume that it is not less than 1. It's greater than 1. Huh? If it's greater than 1, don't you think all these terms would go to infinity? All are even, there's no. So it's going to infinity, then the sum would be infinity. Then it certainly can't be represented in this form, isn't it? Is it fine? And whatever this number is, it can certainly not be a finite number, right? If it's going. So it need not be given in the problem. We can assume that it is less than 1. I'm just saying why did I took the formula directly, right? This is justification for it. So denominator can be factorized as 1 plus 1 into 1 plus x into 1 minus x. One of the 1 minus x will get cancelled. This remains. So simply have to solve x square is equal to 1 plus x, or x square minus x minus 1 is equal to 0. What is this? A quadratic equation. We know how to find. So minus b. So minus b, I'll write the formula itself. B square minus 4ac by 2a. Right? So what is minus b? B is 1 only. So 1 plus or minus root of 1 plus 4ac, which is 4 by 2. So it's nothing but 1 plus or minus root 5 by 2. So b is plus 1 or minus 1. What is it? Which is it?
Plus.
Because plus, why should it be plus? Why can't it be
Otherwise,
minus?
the whole thing will be negative.
If it's negative, do we have any issue if x is negative? We said it should be plus. What is the problem? Why should x be? Is there any condition? Did we have any condition? X should be positive itself. Or
Yes,
x,
sir. Because x will be here. We have considered x is less than 1.
yeah. Okay.
So the whole thing, the sum x square minus x cube, everything will be greater than.
Okay. We'll check the two values. 1 plus root 5 by 2 and 1 minus root 5 by 2. Correct. What is root 5? Little greater than 2. Right?
Yes.
So 2 plus 1 by 2 is greater than 1. This can't be the solution. We have to take the minus 1, not the plus 1. Okay. So if you take the minus 1, again, 2 point something, 1 minus 2 point something is minus 1 point something, by 2, it's fine. It's still, the mod r is still less than 1. You all agree? So your answer, see, if you had taken plus, your answer would have been wrong. Because, see, at the end, they didn't ask you what is the correct answer. They asked you to find the sum of A, B, C, and D. What is A? A is 1. B is minus 1. C is 5. And D is 2. So this is the sum what you want. So usually, whenever, instead of giving the answer directly, so this is what they try to do. Otherwise, looking at the option, sometimes you try to figure out, right? Or you substitute in the, see, you try to substitute, if this answer was given, probably you'll substitute here and figure out something. So what they do is, they tell you this is the answer, you write it in this form, right? And then you do it. Is it fine? So they even gave you, say, D is greater than 0. Why? If D is not, that's not given, you multiply with a minus sign, probably your answer will entirely change, right? If you multiply, write the numerator as root 5 minus 1, you can do it because they just give you A, B, C, D. They didn't give you any condition on the power. So if you keep this positive, then only you'll get A and B correctly according to signs. So that is also. Is it okay? Is it clear? Okay. So one last problem was this. So you can try this as a homework. Okay. So this is not your usual series. This is something called as AGP, arithmetic or geometry series. Okay. But I don't want you to remember that, all those things. How to solve this? do you remember the derivation I did for Sn for geometric series? Use that as a hint. Similarly, try to do this using derivation itself. Okay, you try it. If you don't get it, it's okay. I'll discuss this in the next class. Then I'll start with HP. We'll finish HP and little bit of means. I'll tell you. That should be the last class for progressions. Okay. Okay. Thank you then. Any doubts you can ask.